Okay, so this video is going to finish 1-3 where I got interrupted and then had to kind of cut off my video. So I was at constructing an angle. So we're going to actually use the compass and the protractor and a straight edge to construct an angle. So what if um, I have an angle? It doesn't really matter. I keep drawing them to the right, but open to the right, but you really could have it either way. What if I have this angle right here, and I would like to construct a congruent angle. So this is how this works. You take, this is our original here, so this is the original, right? And I want to construct a congruent one. I start with putting my tip of my compass and making an arc. Doesn't matter what distance you have on here, you just need some distance to go out. Then I'm going to go down and I am going to construct my congruent one. I'm going to start with just a random line. And I'm going to call this the vertex. And I'm going to take this same distance I left it, and I'm going to make another arc. All right, so here I am. I've got this arc, and I have that same distance. Then what I'm going to do is I'm going to go over to the original one, and I am going to move this till it's kind of hard to show this. I'm going to move this in until it matches the distance from one of the arcs to the other side. Let me make sure it's perfect. There we go. See how it matches exactly? So I know this arc is the same distance out as this arc here. So if I go over here and I mark this, then I could see this would be, see, exactly matched. That means this point here matches this point here. And I could then draw my congruent angle. So let's say I was going to test you on understanding a construction. I would need to see all of your arcs and the proof that you walked through the steps. So these are congruent angles, and we could double check that with our protractor. Oop, looks like it's about 35 degrees, and that one's about 35 degrees. So we constructed a congruent angle. This one came out further, so it doesn't look as congruent, but they are. So let's look at what if we wanted to construct a bisector of an angle? So what is a bisector? First of all, a bisector is a line that's going to, or a ray that's going to go right down the center and cut yours in half. So let's start with kind of a bigger one here. So let's draw one. So I'll draw kind of a bigger angle for this. And so here's an angle. I want to bisect this angle. What I'm going to start with is just an arc length out, just a distance out for whatever distance you want to set this at for making an arc. Leave that at that same distance. So I'm going to put the arc and I'm going to leave it at that same distance. And so then I'm going to take from the point, the arc that I made, I'm going to make a slash out here. From the arc point again that I made, I'm going to put a slash out here. And what I did with this is I made an arc, and then I used those 2 points so it's equidistant from the vertex to make two small arcs from each one, and where this crosses is going to be our bisector. So we'll go and we'll line up our vertex, and this line bisects our angle, and you can see easily this is equal to this. It was a really good bisector. So those are the two constructions that it wanted you to learn for this chapter. So let's also go over the angle bisector. So this is the angle, oops, or excuse me, addition postulate. So this is really similar to the postulate last week that we had over the segment addition. Okay, so this one says that if you have a full angle, then the two pieces of it will add up to the outside one. And I'm actually, instead of drawing it, I'm going to show you what they show you in the book here. Okay, so angle addition. So this is the postulate. This is the rule that it tells you. See how it has an angle? And it's saying the big angle, PQR. PQR is equal to the two pieces. And they did one in red, one in blue. And it doesn't matter. Look at this one. This is just totally different one. We know that if we add up these two pieces, it's going to equal the whole. So it's the same with the segments, and then you have to do some mathematical things with that, but we do know that the two pieces will add up to the whole. So what kind of problems are we going to see with this? Well, we're going to see lots of different, let's see, lots of different problems. I'm going to do one. Let's see, so this is my example. If I have SP, and that's the symbol for array, oops, put that out. Good thing I keep looking up at my computer. I keep just writing away and then you can't see it. If this SP bisects angle RST, find angle RST if you have the following information. The measure of angle RSP equals 4x plus 3, and the measure of angle PST is equal to 5x minus 6. So we have this information here. Okay, from here, I'm going to draw this. So you will be given tons of problems. It doesn't draw them all for you. You have to draw them. So I'm just going to draw an angle. Oops, that wasn't the best line. That's okay. And I know SP is going to bisect RST, and we want to find RST, and we have RSP, RST. So what was all this? We know that RST is what we're looking for, and we know SP bisects it. I could construct a perfect bisector on this one with the same rules or the tools we just used and the method we just used. But here is the SP is the bisector of RST. Now look at this information. RSP is 4x plus 3. And PST is 5x minus 6. So if they're bisectors, what does that mean about these two? It means they're equal. So you can actually find x to find the degrees that you have going on in here. We know that 4x plus 3 has to equal 5x minus 6, and you need to solve this for x. So I'm going to minus the 4x over, because 5 minus 4 gives you 1x. This would be 1x. On this side, you still just have the 3, but that's gone. You still have the 6 over here. Now, the x is here almost by itself, but we still have to add this 6 over. So I'm going to add the 6 to both sides, and you're going to get that x is equal to 9. From here, now that I know what x equals, I can find these two pieces, right? So then I'm going to go, okay, well, this piece is 4 times 9 plus 3. So 4 times 9 is 36, plus 3 would give us 39. And then 5 times 9 minus 6, well, 5 times 9 is 45 minus 6. How did I get the degrees? I was looking at my notes and anyway, 5 times 9 is 45 minus, I added it over here, so that means I messed up the rest of my notes. That's okay. Minus 6 is going to give me 39. And so we can see that these two angles are These two angles are equal. That's what we said they would be. They're both 39. And so what's the total one if each piece is 39? Oops, I'm kind of messing up here. Right, you'd add them together. So 39 plus 39 is going to give me 78 degrees is the measure of angle RST. Okay, so the total degrees, and this has got degrees on it. I don't always write it, but I should. All right, so that's kind of one of the problems that you might see, and they don't all have to do with the bisector, but this one was a more challenging problem that had to do with the bisector, so I thought I'd do that. You might just have them where they add up to a certain degrees or different things are going to be missing. All right, so that's my lecture over this section, and hopefully you found that helpful. And there's two parts again, just because I got interrupted, so I had to cut off the other half.